Okay, in this case, we've got a ball that starts in somebody's hand, and the second it leaves his hand, he throws it straight in the air, and the ball begins to climb with an initial velocity of 6 meters per second. So it's no longer in his hand, it's basically in a free fall. And we want to know how high the ball can travel. So it starts to slow down, slow down, slow down until eventually it reaches its maximum height, where its final velocity is 0. And we're trying to figure out how high, what that vertical distance actually is. Well, conservation of energy says all of our energy, if we add it up before, has to equal all of our energy after. And we just have to itemize. Initially, it's the lowest point of the problem, so we're defining that as our ground level, that's 0. So there is no potential. But it does have a velocity, so it starts with only kinetic energy. Initially, it only has kinetic energy. And as it climbs that kinetic energy, it starts to slow down. It gets converted into height, which is potential energy. So right at the top, the kinetic energy is 0 because there's no velocity. And it all gets converted into height, which is potential energy. So 1/2 mv initial squared. My initial kinetic energy gets converted to mgh final. And there's an m in every term, so we cancel them off. And if we solve it for h final, I get h final is v initial squared divided by 2g, which is 6.0 meters per second, all squared, my initial velocity, divided by 2 times 9.8 meters per second squared gives me 1.8 meters, maximum height.